Hi, everybody. I would like to thank the Carahsoft team for giving us this opportunity to be with you today. And thank you, everyone who has joined us today to discuss the fascinating topic of PQC migration. So let's go ahead and get started. This is our agenda for today. Um, we'll try to take a slightly different approach in a sense that we'll try to leave you with some practical guidance on how to actually get started, with the PQC migration, kind of getting beyond what I would call admiring the problem to actually um, figuring out how we're going to start making some tangible progress on getting ourselves more quantum resilient. So let's get on with it. So first, just kind of wanted to um, introduce this analogy, which I think is helpful. I've kind of been using it with some success. Um, and it's really kind of thinking about cryptography as a really foundational thing, something kind of like akin to plumbing, right? It's really ubiquitous, it's foundational, it's everywhere, and you really don't think much about plumbing until something happens, right? The pipes leak, and then all of a sudden it becomes something becomes an urgent issue. And so the thing with cryptography is that largely it just works, right? And it historically just worked, and we kind of just got kind of grown accustomed to it working, and it really has become foundational to, I would say, digital privacy and trust in the digital world, right? It's all kind of really supported, underpinned by cryptography. Now, the problem we all have is, of course, quantum computers are getting more and more powerful. And obviously, the discussion today is that they're going to be able to break our public key cryptography, which again has been so foundational. And so, we're really at a point where our, classical cryptography pipes are about to start leaking, right? And we really need to, as an industry, find a way forward to, as quickly as possible, to migrate to quantum resilient cryptography. But what I think is kind of important to understand is that this period of migration itself will carry risks. If you think about this from a perspective of adversaries, right, there is no better time to sort of try to go after our infrastructure is when we're kind of transitioning from classical to post-quantum. Because the hope is that we're going to, mess something up. We're going to leave some doors open. Or maybe we'll put in the new piping, which we believed to be quantum resilient, but if that new piping is not implemented up to code, obviously when you do plumbing, it's very important to follow code, right? There's a code for a reason. So in the world of cryptography, there's also such thing called code, and the gold standard there is really NIST and FIPS 140, the Federal Information Processing Standard, which really talks about how algorithms need to be implemented, and then there is a rigorous testing that NIST does and the labs do to verify that the cryptographic modules are properly implemented, right? So there's obviously the cryptographic algorithms have to be secure, but then traditionally most of the problems we've seen in cryptography has been poor implementation, right? So the one thing I kind of want you to remember is as you go through this transition, you got to make sure that the new cryptographic modules, libraries you're putting in to replace your classical ones, you want to make sure that they have properly been implemented up to code. And we'll talk more about that as we go through this. So just to level set, I don't necessarily assume any pre-existing experience with this. So I'm just kind of going to just do a very quick overview of sort of what kind of the problem is, right? So essentially, we have asymmetric cryptography, public key cryptography, which essentially means that there is a private key and a public key, and the private key, just as it sounds, nobody knows except you. Public key is open to the world. And so this essentially what enables a lot of the internet communication and kind of ability to use cryptography to enable this at scale. Obviously, if you have two parties that closely know each other, and maybe there's two endpoints talking, maybe you can just exchange a symmetric key and carry the conversation. But for it to be useful over the internet and to really scale, you really do need the public key cryptography. And so the problem is that public key cryptography is based on a class of mathematical problems, kind of difficult math problems, what we believe to be difficult math problems that are difficult to solve for classical computers that we believe are not going to be so difficult to solve for once we have sufficiently strong quantum computers called cryptographically relevant quantum computers because of something called Shor's algorithm that was invented back in 1994, actually, which makes those problems much easier to solve. And usually, in the case of, let's say, something like RSA, it's, you have a large number that's a fundamentally product of two prime numbers, very, very large prime numbers. And, classical computers don't really have very efficient ways to be able to factor that. Unfortunately, not going to be the same problem with quantum computers. And so that is sort of the basis of a lot of our public key cryptography today, and that is unfortunately at risk. And so we have known about this problem for some time. As a matter of fact, the National Institute of Standards has been running a competition for over 7 years to find quantum resistant replacements for algorithms like RSA, elliptic curves, and so forth. Just last summer, they standardized the first three algorithms. So there's been a quantum resistant algorithm. So there's been, one key encapsulation mechanism, so essentially for key exchange, and two digital signature algorithms. And the process is still continuing because NIST is continuing to look for additional quantum resistant algorithms as well. But this is a pretty big deal. NIST started with something like 82 submissions. It went through multiple rounds. It was truly international competition. So folks from the industry, academia, researchers all over the world submitted the algorithms, and in the end, 3 got standardized at this point. So kind of like shows you the kind of rigorous selection process that it went through. So the good news is that we have the new standards, and they're actually also now being added to the NIST testing for FIPS, because like I mentioned before, you really, having algorithm is great, but you also need to have properly vetted implementations. So the same day that those algorithms actually got announced, which was August of last year, NIST also said that they're going to be ready to start supporting, FIPS validation of those algorithms, which is a really, really great thing. So let's talk a little bit about the timing of the threat. I know that sometimes I don't know if excuses is the right word, but there's a bit of a skepticism in terms of how urgent the threat is and how quickly we should start adapting it. And we've heard arguments like, well, when a quantum computer is really going to be powerful enough, and of course before the argument was also, well, we don't have quantum resistant standards yet. Of course, now we do, as of last August. So that is now off the table. But it's still a legitimate question to ask. When might we have what we call a cryptographically relevant quantum computer, CRQC, and what is really the timing of the threat? And so I would like to answer this question in a few ways, but one way to answer is that it doesn't actually matter exactly when we'll have CRQC, because the threat is already here and we're already behind because of how long have previous transformations have taken and transitions in the world of cryptography. And this one is going to be a massive one for sure. But the reason the threat is already here is that there is a class of attacks called Harvest Now, Decrypt Later, HNDL for short. And essentially, it's kind of simple to understand. It's adversaries we don't believe currently have a quantum computer, but they can already start harvesting the data. So maybe there's other types of attacks, or they found a way to exfiltrate the data, right? So they're harvesting the data. It may be encrypted today, so they can't really decrypt it yet. But here's the thing: if the data is still sensitive when CRQC comes online, then they decrypt it then, and it is a problem. Um, so, especially where you have sectors that are rich with sensitive data, certainly a lot of the government organizations, um, financial sector, healthcare, telecom, and others, right? You have sensitive information. And so those sectors are beginning to think now about this threat. So for them, essentially, any day that goes by, and if they have any of the data that gets accessed, even if it was encrypted, the concern is, could it be decrypted later on? So we're kind of dealing with this threat right now. So for that reason, really, there's really no time to lose, right? The other thing to kind of keep in mind is that it takes a very, very long time to migrate, to transition to new cryptographic algorithms. And this one is going to be a huge transition. Like, we literally have not seen anything like this before, to really have to migrate all of our PKI, all of our symmetric cryptography to quantum resistant cryptography. So if you look at the history and kind of use the history as a guide, um, there's, for instance, SHA-1, well-known, secure hash algorithm, which was first deployed in '95. It was used pretty extensively in TLS and SSL certificates and all of that. In 2005, there were some first theoretical attacks. So it really started showing cracks 20 years ago that essentially, you can have problems with SHA-1. And by 2011, so 6 years later, NIST actually said it's deprecated now. We don't recommend using it. And it recommended transitioning to SHA-2 category of hashing functions. 2017, actually, Google announced that they successfully hacked SHA-1. So it's not just theoretical cracks. It's actually showing that it's no longer adequate, right, and can be compromised. Uh, and when that happened, um, you know, research was done to show that as many as 35% of the websites were still using SHA-1. And I will assure you that if you were to um, do scans right now, you'll see many organizations are still using SHA-1 for one reason or another in pretty high numbers. So it is still there 20 years later. And that is just one hashing algorithm, right? This is, a far more modest transition than the one we're looking at with PQC. But, if you kind of look at that, how difficult it has been and how long it has taken, you kind of begin to get a sense of the journey ahead. And so if you combine the fact that you have the harvest now, decrypt later, and how long those things really take, you really kind of reach the conclusion that we're already behind, right? And whether or not it takes 5 years, 10 years, or 15 years to see a cryptographically relevant quantum computer, we are already in a position where we really got to keep moving. So Gartner recognized that, actually, and just in October of last year, Gartner published a report, which I thought was really great. It was a top strategic technology trends for 2025. So as you can see, it has, various AI things and human machine synergy, topics. And then you have the new frontiers of computing. And so it was kind of interesting to see that post-quantum cryptography has made the list. It has made the list of um, something to worry about as a top technology trend. And this is kind of what gets consumed by the CTOs, the CIOs, the CISOs. So this goes all the way to pretty high senior level of the organizations that consume this information from Gartner. And Gartner, in fact, said that they believe that by 2029, quantum computing will make existing classical, asymmetric systems unsafe to use. So, that's 4 years from now. That is not a long time. So that means again, the best time to start is really now. NIST actually also recently, just in January, published some guidance. So after they published the standards in August of last year, um, in January of this year, they actually published um, essentially a roadmap of when they plan to start deprecating um, classical asymmetric schemes. Um, so that means again RSA, elliptic curves, Diffie-Hellman, stuff like that, right? That's based on either prime number, factorization or discrete log problem, right? Those things will get deprecated. And most of them will get deprecated either by 2030 or by 2035. So, they initially get deprecated and they get disallowed. So deprecated kind of, I guess, puts you on notice, and disallowed, which means literally if you want to have a NIST validate module with Federal Information Processing Standard, FIPS, if you still have RSA after the year, 2035, your module can no longer get validation, or if it was active before, it will go to the historical list. So NIST is really putting a stake in the ground to say, look, we believe that these things will no longer be secure, within a decade. Again, decade might seem like a long time. It's really not when you think about the scope of the migration challenge that we're facing. And it seems like just in the last 6 months, just kind of since NIST announced the new quantum resistance standards, there's just been continuous kind of stream of news coming out, really with the progress that's being made, with quantum computers and kind of progress in this area. So for instance, in December, Google announced, you might have, many of you, I'm sure, heard about this, the Willow quantum chip. So the big news there is, one is just tremendous, pickup in ability to do certain types of, calculations. So 10 to the power of 25, just a staggering number. But the other thing is reducing errors. Because one of the challenges with building quantum computers that are useful is that as you add qubits, as you add the quantum bits, the error rates also go up. All right. So when the error rates go up, you kind of need to have error correction, or you need to have a whole lot more bits, so depending on the error rate. So anything that significantly reduces the number of errors or makes improvements in, say, the error correction is really key to being able to build quantum computer. That's and quantum computers, we kind of talk about threats from quantum computers. I mean, they're gonna bring a lot of benefits. I mean, there's a lot of great reasons to build a quantum computer. The side effect that's unfortunate we're talking about here in terms of cryptography, that's what we're dealing with. But anyway, so that was a pretty important development from Google just in December. And there were some other developments as well, right? So let's kind of talk about that. But first, just to kind of get back to what NIST has done in August. So I was actually honored to attend a meeting that the White House hosted on August 13th. It was actually an interesting day for me because I was with my family on a summer vacation with the kids. We're out in the Outer Banks, and then I had to tell my wife honey, is it okay if I, fly back to DC on August 13th? I think, because I didn't know exactly what was going to happen, but I had a suspicion. I was like, I got the invitation. I believe new quantum resistance standards are going to get announced. Um, so she was like, okay, go. So I was like, okay, I'll make a 1 day trip. In Outer Banks, there's not really an airport conveniently located, so it takes like 2 hours to drive to Richmond, and then you fly to DC, and then you come back. So it was a long day, but it was well worth it. Indeed, the three standards got announced. So MLChem, which is a key encapsulation mechanism, it's for sharing the key material between parties that don't have any pre-existing trust between them, right? And then MLDSA and SLHDSA are the two digital signature algorithms. So, it was a pretty big deal. And I got to say that, the United States government and NIST have really taken a leadership position in this, right? Starting this competition over 7 years ago. And really kind of making this something that was, um, you know, anybody who wanted to be represented could have been represented, right? So people from all over the world again made submission. It was a very open and rigorous process. So done a fantastic job. Plenty of reasons to celebrate. So yes, so announced the three standards, and also, like I mentioned, announced uh, both CAVP and CMVP testing for the algorithm. So they're both part of NIST and kind of the FIP standard. CMVP is the full cryptographic module validation program, and then CAVP is algorithm testing, which is kind of a component of the CMVP for these algorithms. Because again, uh, it's great to have algorithms. I can tell you that a lot of the implementations that were used for the competition were kind of reference implementations, but there's definitely a distance between a reference implementation and having, a fully baked commercial grade implementation, which is kind of what we specialize here in SafeLogic. So it's great to have those CVP and CMVP programs as a way to keep us all honest in terms of making sure that we're implementing these algorithms properly. So again, just to kind of get back to the development, so there's been a couple that came out here fairly recently. So actually, China just announced recently that they have a 504-bit superconducting quantum computer, kind of rivaling IBM's quantum computer. At least that's what's alleged in terms of qubit lifetime and the readout fidelity. Again, kind of going back to that error rates and all of that we just talked about. And Russia just recently also announced a smaller qubit, so 50 qubit supercomputer, but using a different approach that is allegedly going to be, pretty scalable to thousands of qubits. Again, this is kind of what's being alleged. Now, it's important to note that with quantum computers, right, there's no sort of one approach to build them. There's different approaches. We don't know. Ultimately, maybe one or two will end up being the best ones. But right now, people are trying different approaches. But the other thing just to kind of keep in mind is that it's important to be sort of, take it with a grain of salt in terms of what we're hearing from countries, especially our adversaries, but just anybody in general about their real quantum computing capabilities, because ultimately, whoever can build a CRQC right first, I mean, this is going to be a pretty big deal, right? It's kind of like, think about when the British build a computer that, right, Alan Turing, like to be able to crack Enigma, right? That was the closest kept secret, right? Because that gives you a lot of power when the other party does not know that you can actually access and decrypt their data, right? So I would kind of take all that news a little bit with a grain of salt, and I would assume that if this is what's being announced, maybe the real capabilities can be beyond that, right? So just as food for thought. We haven't been standing still. I have to I have to give our government a lot of credit just in terms of really being in the forefront. There's been a couple of executive orders, and there's even a Quantum Cyber Preparedness Act, which really, is asking initially the agencies to start focusing on this problem, initially on inventorying and cost estimates. So essentially creating an inventory of here's, where I have all my cryptography that, may be vulnerable to classical to quantum computers, so asymmetric cryptography. And that's a big lift for many organizations because that does not really readily exist in most places. And then generating cost estimates for migrating to post-quantum cryptography. So what is it really gonna entail? And I would say that I think it's fair to say that agencies, by and large, have struggled with this task in terms of both accuracy and actually just being able to do this in the timeline that the government has been asking. And that is really not just unique to the agencies, but in general. I would say outside of maybe certain more mature organizations like, let's say the financial sector, I think tends to be a little bit further along with this. Most organizations haven't really had a good, I would say, a rigorous management function to their cryptographic assets in general. So kind of when you start asking them, well, what do you have and what do you use? It is a difficult question to answer if you haven't really had like a capability stood up to do this. And again, this is not sort of just the agencies. I think this is just the state of how we are in general. So for instance, we were in this kind of environment when it came to supply chains, right? So we realized, okay, there's a lot of supply chain attacks, software supply chains. So now people are understanding you need to have a software bill of material. You need to understand what's actually in your software, right? And that has kind of become the standard. But something like a cryptographic bill of material, or CBOM, is far from being standard, right? It's a new concept. So eventually the world will need to get there, but there's definitely a big journey. And so that sort of makes this transition challenging. So when agencies have been asked to do this inventorying, they turn to a class of essentially cryptographic asset discovery tools. So there's a number of vendors out there that do cryptographic asset discovery. Essentially, scan your networks, your applications, your file systems to understand where you might be using cryptography, what kind of cryptography it is, and give you some sort of a report. And there is various purpose-built commercial tools that exist for cryptographic asset discovery. So one of the things I would like to tell you is that it's certainly necessary to do that. It's important. I will also say that it is not sufficient, right? It's a good step. You will need other things in that journey. I actually have the privilege of working with NIST, the Center of Excellence, and I'm currently running the PQC migration risk management prioritization workstream. And there we have NIST lab, and in the lab we are actually using and running quite a few of these tools. And they're great tools and provide great results. So why am I saying they're necessary but not sufficient though? There's a few reasons. One is you will run the tool, you will come up with a very large number of results, right? And those results will need to be, and when I say large number, literally it could be tens or hundreds of thousands of results that you will get. So you will need to normalize it because you might have different tools reporting things differently, and maybe there's duplicates. You'll need to normalize it. You need to correlate it to your data and assets so that you can start prioritizing, right? Because you really need to know what data is in question that's being protected with those cryptographic controls. So going through this normalization, correlation, prioritization is not straightforward. And this is actually what we're trying to tackle right now with the NIST work, and hopefully we can report on that and to the world to help them with this problem. But it is a big challenge. You also really need to have a plan and ability to address the findings. So what are you going to do with the findings, right? So you kind of really gotta have a cryptographic asset management program where this is going to get plugged in, and so that the PQC migration is not just a point in time kind of thing, but it really gets plugged into the overarching cryptographic asset management program, which again, most organizations do not have today. So you would need to stand one up as a function, which is obviously very different from just running a tool, right? It's creating a capability. So this is something to to keep in mind, and we'll return to that some more. I will also say that there is as part of kind of thinking through the adoption, there is a growing interest in hybrid approaches for post-quantum cryptography migration. And the idea is that as we migrate, we may want to initially, before we go full-fledged, just go to pure PQC, we actually may use both the classical cryptography and PQC together. Think of that kind of as the two layers of encryption. And there's different views on that. Certainly introduces some complexity to do that. And complexity in general is the enemy of security. So there are those that make, I think, valid arguments that maybe we shouldn't do that. But then there are other arguments in terms of doing that, because essentially what you get is defense in depth, right? If you think some of the PQC algorithms are still a little bit new, it maybe makes you feel a little bit better to kind of have two layers such that you have a layer of classical, level of PQC as well. So you kind of do both, at least for a period of time. The other thing there is in terms of compliance, if agencies have the requirement to start migrating to PQC, but they also have the requirement to be using FIPS 140 validated cryptography. And it's going to take some time until you have fully validated FIPS 140 cryptography, because it just takes some time to go through the labs and NIST. This process can take a couple of years. So in the meantime, if you use a layer of FIPS validated classical with a layer of PQC, you kind of get to check both of those boxes, right? You get the FIPS compliance box and you get the PQC box as well. So you get defense in depth, and you kind of get that, compliance. But the trade-off, it can be a little bit more complicated, right? And so that could be a problem in certain settings. So it's really kind of for each organization to decide, by themselves what they sort of want to do in that respect. So let me kind of give you what I would consider sort of the 4 guiding principles for PQC migration. They are a little bit, high level, but I think it's kind of important to really internalize them, because I think they will really help you as you go through this journey. So the first one I would say is having a bias for action, right? Like we started the session saying, don't admire the problem. Yes, the problem is there, but let's actually dive in and figure out how we start solving it one bit at a time, right? It's like how do you eat an elephant, right? One bite at a time, right? So it's important to think not just planning, but actually getting beyond the planning and start implementing and doing and migrating. So what you want to avoid is kind of paralysis by analysis, right? So you kind of want to, there's no time to lose, and you don't really have 2 years to be planning and then sort of thrashing and kind of figuring out, you really want to start getting on with the work. The other thing that I mentioned, and I think this is really important, is you want to start thinking about building out a continuous cryptographic management, right? And kind of treating this as a journey where you are increasing the maturity over time. And usually, it might involve creating some sort of cryptography center of excellence, which I'm sure most of you do not have today. But it's really kind of creating essentially a function within your organization that is going to be responsible for managing this important asset and important use that you have around cryptography. And by the way, that will have other benefits as well, not just PQC migration. For instance, Much has been said about ransomware attacks and so forth. Well, if you think about ransomware, in some sense, what is happening there? The adversary is turning your cryptographic infrastructure against you, encrypting your own data, right? And then holding your ransom. So if you have a cryptographic center of excellence that dictates what cryptography you're using, when to encrypt, when not to encrypt based on policies, for instance, you could start, addressing that problem as well, right? And there's going to be future cryptographic migrations as well, right, outside of PQC. And this is why you kind of really want to manage that as a rigorous, function within your enterprise. And you've probably heard this term crypto agility. What is crypto agility? Well, crypto agility, I would say there's no universal definition. I can tell you people kind of think about this a little bit differently. But the way that I sort of think about this is, when you have future cryptographic transition, you have to get a new algorithm or you have like a vulnerability that gets discovered. How much pain is it going to be for you to actually move to something new, right? Are you going to have to go and touch all your code, recompile your applications, right? And kind of do a lot of the heavy lifting, or is it just going to be changing a configuration somewhere, configuration representing your policy, and boom, it just gets applied, right? So crypto agility is really reducing the degree of pain and making it as easy and frictionless as possible for you to go through future cryptographic migrations. For many organizations, the degree of crypto agility that we'll have today will not be great. So the idea is as you go through this PQC migration, to really, hopefully, as part of standing up this cryptographic management function, to build in crypto agility into your infrastructure so that when you do the PQC migration, and hopefully you are migrating to solutions that are allowing you to be crypto agile, that you are would not have to endure the same pains or challenges that you might have to endure right now to move to the more crypto agile model. But anyway, just kind of wanted to make sure you understand that it's not just a one and done PQC migration. It's really getting a handle of your cryptography and managing it, and PQC migration is sort of a byproduct of being able to do that in a sense. The other important thing I think to keep in mind is you want to sort of look at it as an iterative approach, right? And I mean, in the world of IT, we have long, I think, understood that there are better approaches than waterfall, right? That you have iterative approach, which kind of reduce your risk and kind of allow you to do things in stages, in sort of sprints, right? Most of the time, when I look at the different literature on PQC migration, it is very much looking like a waterfall approach to me. Like, let's do some discovery, let's do some planning, and then maybe we start doing something. So it kind of looks like let's spend a year here, a year there. And I think that's fundamentally not the right approach. I think what you really want to do is to start doing these things again in sprints. Let's find some low-hanging fruit that you can start making quantum resilient, achieving some quick wins. And essentially the idea is let's be more quantum resilient each day. Let's be better tomorrow than we were yesterday, and so forth, right? So let's just get on with it. And actually, again, I got to give credit to Gartner. Gartner has been sort of talking about this crypto agility and PQC migration kind of as a DevSecOps activity, which I think is correct, right? It's this is how we do development these days. This is how we do IT these days. There's kind of no reason not to think about this in the same terms. The other thing that I want to encourage you to do is to really break down the scope of work, right? So think about PQC migration, and broadly, I can think of three buckets of work, right? When you look at your environment, you may realize, okay, you have cloud service providers you're using for certain things, AWS, Azure, whatever the case may be. Some of those things will be perhaps their responsibility as far as quantum resilience. Now, everything here is your problem because it's your environment, your data. but you may be able to lean on the CSPs or, kind of on what they're doing. So that's going to be one bucket, right? That you can just kind of, okay, let's figure out the CSPs are doing the right thing, and you can put it aside for a second. Then you have the other third-party vendors that you have. So you should definitely start having conversations with your vendors about what is their approach for quantum resilience, PQC migration, and hopefully they have an approach. If haven't thought about it, don't have an approach, maybe you need a different vendor. So definitely that's going to be another bucket. And then there's going to be your own stuff, right? Your own code, your own infrastructure. And I would postulate that an 80-20 approach will apply here. That last bucket may be maybe 20% of your stack, but it's probably going to take 80% of your effort, because this is going to be the things that are going to be, you're going to be on the hook for to migrate and do yourself. And this is probably also a good place to start, and hopefully find some low-hanging fruits and start moving on with it. But I think of breaking the problem like that helps you sort of having a mental model for how you're going to attack the problem, and that will help you get started. Again, the idea is to get started. So let's get to some recommendations. So there was actually a great report that came out over the holidays, actually, by the Dutch government. So there were several agencies that put this together in Dutch government. It's the PQC migration handbook. It's the second actually volume they did. They did the first one some time ago. This is the second one. And I got to tell you, you can see a link to it here. I would encourage you to take a look and read it. This is a great resource. I've looked at many different resources. This one kind of stood out for me. It's very, I think, practical. I think it really does sort of does a good job really getting down to the nitty gritty of like actually what needs to be done, right? So I will summarize a few things for you, just but again, I would encourage you to take a look at the report. But essentially, it starts with, kind of, you want to conduct organizational risk assessment. Because, your organization will be, each organization will be different, right? And so, and I know we talked about this webinar being, sort of agencies, integrators, vendors, but the reality is that this will really apply to everyone. However, each organization will be unique. So you really want to look at your organization, start asking yourself the question is like, what do I really need to protect here? What are my crown jewels, right? What am I concerned about? What data do I have that's very sensitive, both very sensitive and long-lived, right? Such that if quantum computers appear 5-10 years later, it's a problem for me, right? And I'm worried about harvest now, decrypt later attacks today. So that organizational risk assessment threat modeling is important. Maybe you already have it, because you already have some sensitive data analysis that you've done. That would be great. If you haven't done it, well, that would be a great place to do it, right? Because it really will help you with the planning and prioritization. So you kind of really know what the scope of what you need to protect, and based on factors like, again, sensitivity, longevity, you can start doing planning and prioritization around remediation. And in some cases, you may say, well, I'm not actually going to migrate to PQC. Maybe there's some other compensating controls you can adapt. Maybe you can use symmetric as opposed to asymmetric cryptography. So there may be some options there for you to pursue. The other thing is making sure that you integrate this and plug it into your existing risk management practices, right? So this kind of goes hand in hand with kind of having this be a cryptographic management function versus just kind of thinking about it as a point in time PQC migration. So if it's going to be a function, don't let this be like a standalone function. Ideally, you already have a risk management program that this can be tied into, right? And this is really, it should be tied into that, right? So think about that. May be different. That will be different for each organization, but think about how you currently manage your risks and where can this get plugged in, with your organization, right? Then as far as remediation, make sure again that as you're remediating this, that you're remediating this in a crypto agile way. Think about this, okay, if I do this change right now, and tomorrow this algorithm, MLKM or something else, right? There is some issue and I need to replace with something else. How much pain will I endure, right? So make sure the solutions you're adapting are crypto agile, right? Such that you can do those future migrations with the least amount of pain. And again, be prepared to iterate and improve continuously, right? It will be done in sprints. You got to start somewhere, and I will tell you in just a minute here, maybe what's a good place to start. And just, be prepared to iterate, right? If you're thinking about this, I'm going to do like a year of planning and, a year of discovery, you're probably not thinking about the right way, to be honest with you. So think about this again as a iterative agile exercise. And again, frame it as maturing the cryptographic management function, which will enable your PQC migration, but it will also have benefits from a security perspective beyond PQC migration. And you can actually use those benefits to sell the large organization on doing that. So, it's a SafeLogic webinar. So let me just tell you a little bit about how we can help here in this endeavor. So we're a cryptographic software company. We've been around for over a decade. Our bread and butter is actually we provide FIPS 140 validation of service. So we have solutions for modules that have been already vetted by NIST and through the FIPS process, so you can adapt it. And rather than going through like a 2+ year process with the government, you can just use our modules, and we can essentially in the span of 8 weeks, we can get you certified and be ready to go. And so we've also been, really focused on the post-quantum cryptography for obvious reasons. So our modules are currently, going through the FIPS validation for all the new algorithms. And so we'll tell you a little bit more about that as well. But we're definitely would be excited to support you in that PQC migration journey. If you think about sort of some of the properties that you want to have as you're going through this process, you want to have a solution from PQC migration that's comprehensive and also interoperable, right? So you really want something that will cover your whole environment. Like you don't want to solve for 80% of the problem, you want to solve the whole problem. So and you also want something that's as interoperable as possible, such that ideally you don't have to do too much surgery. You can just plug it in, right, in your environment. You want to have something that's maintainable. It's kind of another word for crypto agile, right? So maintainable, so over time, it's easy to maintain in your environment. As things change, you don't have to make a lot of changes to absorb them. Obviously, security is important. Demonstrable compliance, something that has actually gone through the validation process like the NIST FIPS and received those certifications. And you really want to have commercial grade support. A lot of the world right now is relying on open source, which there's a lot of great open source for cryptography. But we think that people are going to need more than just the open source as they go through the PQC migration because of the complexity of their environments, complexity of migration. We think organizations are just going to need more assistance. And so we have our software called CryptoComply, which we use for our FIPS 140 validated offerings, but also is what is foundation for our PQC solutions. So we are adding all the PQC algorithms. As a matter of fact, one of the PQC algorithms, MLChem, just last week we received our cryptographic algorithm validation program CAVP certification. We're very excited about that. We use it in our new product, CryptoComply PQ TLS, which I'll tell you about in a second. But we're also engineering for crypto agility in many different levels. Hybrid mode we talked about a little bit earlier, kind of being able to offer you the PQC, but also FIPS validated classical FIPS 140-3 from SafeLogic, such that you can kind of have both the PQC and the FIPS compliance. Things like CNSA 2.0 support, memory safety, and some other things. I mean, those are some of the guiding design principles for our solutions. We sort of cover a wide array of operating systems, programming languages, drop-in sort of compliance with different open source. We have people that use our solutions anywhere from embedded and mobile devices to mainframes and everything in between. Cloud, servers and premises, servers in the cloud. And again, really everything in between, because again, you want to our goal is to be able to cover the whole environment. And so as you migrate to PQC, we want to be your partner to help you across your whole stack. And I just wanted to tell you a few words about our latest product called CryptoComply PQ Post-Quantum TLS. And it's a drop-in replacement for OpenSSL 3, which is very popular out there, TLS 1.3 implementation. So it's used pretty extensively. Apache, Nginx, I mean, it's really all over the place. Again, we have a commercial grade implementation of this thing with CAVP certification for MLChem, like I just mentioned. You can use it in a pure PQ mode. You can use it in hybrid mode. So we don't sort of make the choice for you. You can decide how you want to do it. It offers superior performance. We've actually tested it. That's actually our post-quantum implementation offers something like 20% performance improvement over the classical, for the TLS handshake, which we're pretty excited about. And we're also excited about the policy-based crypto agility. So again, you can drop it in. It literally installs in minutes. You don't have to change your infrastructure in any sort of significant way. And it's all policy-based. So there's literally configuration. So if something changes, your security team or your compliance team can just change the algorithm you want to use, or if you want to go from hybrid to pure PQC or the other way around or something like that, you can do that. And all of that just gets adapted, and you don't have to change any code, don't have to recompile anything at all. I mentioned the NIST and NCCoE, so we're actually using this new technology from SafeLogic in the lab with NIST, and we're kind of using it to demonstrate the end-to-end use case for, from discovery going all the way to remediation. So you discover quantum vulnerable TLS connection, you remediate, and then you do remediation verification. Again, be able to kind of take one use case and carry it all the way through. So you might wonder, why am I talking about TLS and why, I picked this particular product for a reason. We have a lot of different solutions in SafeLogic, but I think this one is kind of important to talk about because, it's an example of what we just were talking about, of taking the iterative approach and kind of going after what can be a low-hanging fruit and fairly easily making some changes that will really have a tangible security benefit. So TLS is a highly robust protocol. It does allow seamless backwards compatibility. So for instance, if you're talking to somebody that doesn't maybe talk PQC yet, you can downgrade and you can go back and talk classical to them. But of course, if both sides are PQC ready, you can kind of do that either pure or you can hybrid. So you have all those options. It's widely used by web browsers, web services, email services, and so forth. So by being able to go after that, you can kind of like take a large swath of the problem and start addressing it. And the good thing, you can do that, again, without having to re-engineer your environment. So you can kind of start addressing that. And also, by the way, we talked about harvest now, decrypt later, right? So if you have those TLS connections, right, and you have the session key that's fundamentally gets exchanged after you have this TLS handshake, which uses PKI. If you make that quantum resilient, then all those session keys are now protected, so you now don't have to worry about harvest now, decrypt later. And again, you can adapt this fairly easily. It's a nice low-hanging fruit type of thing for you to get started with, and you can kind of address that part of the problem, and again, be more quantum resilient tomorrow than you are today, and keep plugging away from that. So if you remember anything from this presentation, is bias correction, getting started, building this cryptographic management capability, and doing this in an iterative approach, getting some quick wins is much better than treating this as a large kind of waterfall project. So with that, I wanted to thank again Carahsoft. Our software is available via our partners Carahsoft. So again, thank you for opportunity to be with you today. Thank you for your time and attention. And at this point, I will take questions.